Hi coders, CS Time channel here, and this video discuss about how to insert a node in the middle of a doubly linked list. To insert a node in the middle of a doubly linked list, we need 3 pointers. The first pointer is a head pointer, is a pointer to point to the first node. And then the second pointer is a tail pointer, is a pointer to point to the last node. And then we need another pointer which is help. Help pointer is a pointer to move from one node to another node. Suppose we are given a doubly linked list like this that consists of alphabet in ascending order. To be able to insert a new node into this doubly linked list, we need the help of pointers. The first pointer is a head pointer that point to the first node. And then we need the second pointer that point to the last node. Here I use tail. And then if you wish to insert a new node like this, my data is C. As a human, it's very easy for us to know the correct position of this, which is here. However, it's not that easy for the computer to do so. To help the computer to do so, we need the help of another pointer. Here, we use help. Help point the same node that pointed by the head. And then this help pointer will traverse from the first node to the following node and to the following node until it finds the correct position to place the C. To be able to do so, then the new node, which is C here, will be compared to the help.data, which is A here. Since the doubly linked list is in alphabetic order, then we will compare if C is greater than A. If no, then the position of C must be here. Otherwise, the position of C may be after this node, here. Now, we will compare the help.next.data, which is B here, compared to the new node. Is C bigger than B? If no, then the position of C must be here. Otherwise, may be in the following node. Now, we move the help to B. Then we check again if new node bigger than help.next.data, which is D here, compare it to the new node. Is C bigger than D? If no, then the position of C must be here. Otherwise, may be in the following node. So in this case, C is not bigger than D, then the position must be here. Now, we can attach the new node, which is C here, in between B and D. To do so, then we have to pay attention to the next pointer belong to C here. We tell the new node.next point to the help.next like this. Next, we pay attention on the help.next.previous, which is the previous of D, to point to the new node like this. And then now we pay attention to the pointer of the help. The help.next, instead of point to D, we tell it to point to the new node like this. And now we pay attention to the previous pointer belong to C. Tell it to point to the help like this. So this is our new doubly linked list. And if we organize it, it will look like this. Let's see the Java implementation. So we will write the method for the insert mid using the previous program we wrote. So in the previous program, we have list node class that has next and previous pointer here. And then we have data that I declare it as character. And then we also have the head pointer, tail pointer, as well as length that I declare as integer, and the purpose of length here is to count the length of the node. In the previous video, we also already initialized the doubly linked list for head and tail with null and then the length with 0, and then we also wrote the code for how to display forward, and then we also wrote the code on how to display backward, and then we also wrote on how to do the insertion in the beginning or insert first, and then we also wrote the code for insert last or to insert a node in the last doubly linked list. Now let's write a method to insert a node in the middle of doubly linked list. So we will declare it as public, the same with the insert plus as well as insert in the beginning, and it will not return value. Now we need to create the object for the new node. This data come from this So after we create the object, now our first job is to compare the new node to the first node pointed by the head. Check if new node dot data is it smaller or equal to head dot data. If it's yes, it means the position is on the left of the first node. Therefore, we need to tell the new node dot next to point to the head, and then we need to tell the head dot previous to point to the new node, and then we move the head to point to the new node, like that. But if the new node is not smaller than the head dot data, it means the position is on its right. So we will need else here. We need the help of another pointer that we declare it as list node here. We need help. We declare it as list node, and then we tell it to point to the first node pointed by the head, like that. So we tell the help to traverse from the first node to the last node to find the correct position for the new node. So here we will need looping while new node dot data bigger than help dot next dot data. We tell the help to move to the next node. Help is help dot next. When the new node dot data is not bigger than the help dot next dot data, so we need to adjust the pointer belong to the node. So new node dot next must point to the help dot next, exactly like in our visualization, and then help dot next dot previous must point to the new node. Help dot next must point to the new node, and then the new node dot previous point to the help. So let's see it one more time. So to insert a node in the middle of doubly linked list, at first we need to create the object for the node that you want to insert, and then what's the data here, and then we will compare it to the first node pointed by the head. We compare the new node data to the head dot data. If it's less than, then the position must be on the left of the first node. Therefore, we need to adjust the pointer belong to the new node dot next must point to the head. And then the head dot previous, this is revert to the previous pointer belong to the first node, must point to the new node. And then we move the head pointer to point to the new node because the new node become the first node. Otherwise, it means the new node dot data bigger than the head dot data. Otherwise, it means the new node dot data is not less than or equal to the head dot data, or in other words, it's bigger than the head dot data. Therefore, we need the help of another pointer, which is help here, and then we tell the help to traverse from the first node to the following node as it compare the data if it's bigger than the help dot next dot data. So we compare it to the next dot data. So if the next dot data is not bigger, then we will quit the looping. It means the correct position is between the help and the next. Now we adjust the next pointer belong to the new node to point to the help dot next. And then we adjust the previous pointer belong to the node pointed by the help to point to the new node. And then we also adjust the next pointer belong to the help to point to the new node, the one that we want to insert. And then the previous pointer belong to the new node should point to the help. Let's test this method. Before we test the method, let's see the previous program first. The doubly linked list has A and then Z and then point to the null. Now we want to insert in the middle, insert mid, and say we want to insert C here. Then we will see the result. Okay, let's run it. At first, we insert A and then Z and then we display it. Here is the result. And then we try our new method, insert mid, we insert C. The C insert it in the middle like this. We can try one more time. We can try one more node here. Let's see the result. A, C, D. I hope this tutorial helped you. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.